Good afternoon, and thank you for joining us on our call today. My name is Christina Spearman from Transcat, and I'll be your moderator this afternoon. Our webinar topic is elevated body temperature measurement with IR thermometers and TI cameras. This topic is being presented by Michael Seaholm and Han Tran from the Fluke Corporation. We expect today's presentation to last roughly 40 minutes, and then we'll answer any questions that have been submitted. During any time during the presentation, you can send questions through the question box to the right in your webinar controls. I would like to mention this webinar is being recorded. Each of you will receive a follow-up email with a link to the recorded webinar and the slides of today's presentation. At this time, I'm going to turn the presentation over to Michael to get us started.
Awesome. Thanks, Christina. Can you hear me okay?
Yep, hear you loud and clear. Okay.
Great.
Thanks.
All right. Well, thanks, everybody. And thanks, Christina. Welcome to today's webinar on elevated body temperature measurement with IR thermometers and TI cameras. So on the agenda today, Han and I will go through some quick introductions on ourselves, and then we'll go ahead and jump into the content, starting with what is elevated body temperature screening and what technologies are available today for EBT screening. We'll get a look at what guidelines the FDA has put out around EBT screening, and then jump into some discussion on each of the technologies, being TI cameras and the IR thermometers. We'll look a little bit into what to look out when you're purchasing an IR thermometer, since there's so many out there today. And then we'll kind of wrap up by talking about the EBT products that Fluke offers, with some, closing out with some question and answers, which Christina mentioned can come through the chat. So quick presenter introduction. So I'm Michael Seaholm. I'm one of our product managers within our safety group at Fluke Corporation. I've been with Fluke for about 2.5 years now. My background and degree is in electrical engineering, but at Fluke I've been in a number of business roles around product innovation and product management. And then I'll go ahead and let Han introduce herself.
Hey, thanks, Michael, and thanks, Christina, for this opportunity. I am Han Tran, as Christina said. I'm a product manager on the same team as Michael Seaholm, as you can see here. And I've got a little bit of background in thermal imaging, actually recent dose of education being on this project. So it's been a lot of fun. And we'll go over some of the project that I've been working on, the FS100. You'll see later on.
Great, thanks, Han. So we'll jump forward here. So we'll jump into why evaluate EBT in the first place. You see it going on at, whether it's restaurants, going to the dentist or doctor's office, getting into the office for those that are still going. So why are we doing it? Well, I'm sure, as many of you know, fever is a very common and often the very first symptom that you'll see of COVID-19. And it's just one way that we might go about identifying individuals who potentially have COVID-19. And evaluating with our contact thermometers today is just not efficient. It requires cleaning in between use, and there's obviously concern about contamination and screening in this way. And so the most popular technologies that have pushed forward for efficient fever evaluation have been non-contact forms of temperature measurement. So when we're looking at non-contact EBT, or elevated body temperature evaluation, it can be accomplished with really two prevalent technologies that we've called out: IR, or infrared thermometers, and thermal imaging cameras. So with the IR thermometers, what's going on is that temperature is being measured by essentially taking an IR measurement. All objects, beings above essentially absolute zero give off IR radiation, and we can tie that with a correlation to temperature. And so IR thermometers are using a spot measurement on the skin with some sort of offset to try and determine your internal body temperature from your skin temperature. And then obviously with this picture that we have here on the left, this is a thermal imaging camera. It's essentially a 2D infrared scan across the entire face, where they're often using the inner canthus or the inner eye tear duct area, again with some sort of offset to try and determine body temperature from your outside skin temperature. So looking back at a 2019 FDA study on thermal screening or elevated body temperature screening, they conducted a study with a little over 1,000 individuals looking at the correlation between the forehead, the inner eye, and other areas on the face. And you can see from the forehead single spot as well as the canthus or the inside, the tear duct single spot, you get some pretty low correlation in the R squared equals 0.21 to 0.3 for the forehead and from 0.47 to 0.49 for the canthus. And what was determined is that finding the max region, the max temperature across the entire face using a thermal imaging camera was actually the highest correlation amongst all of them. And so, if we look in the table in the bottom right here, the inner canthus was about 75% of the time where you would find the hottest temperature on the face, with 11% coming from the forehead or the hairline, and then the rest coming from nose, temple, or other parts of the face. And so essentially the conclusion was that the best way to go about screening is to identify the hottest temperature on the entirety of the face, which was most often the inner canthus, and that's going to be the way that correlates best to finding your internal body temperature. And so, as we entered into this pandemic, at the start of the year, we, towards the end of March, declared a national state of emergency for COVID-19, and that is declared by the Secretary of Health and Human Services. And so at that point, the FDA stepped in as there weren't enough certain types of medical devices to go around to try and help screen out individuals who potentially might have COVID-19. And so in April of 2020, the FDA issued a series of enforcement policies for a subset of medical devices that were deemed low risk to go through this process. Instead of having to go through a formal medical device pre-market authorization, what these enforcement policies allow is that manufacturers can produce and market both non-contact thermometers, non-contact IR thermometers, as well as thermal imaging cameras for the use in fever screening or elevated body temperature screening, as long as the requirement and standards within the enforcement policy were met. So in summary, there's no submission of information or any data that proves that you've met these requirements, but if the FDA audits you, you have to keep a compliance file on hand to prove that you've met everything in the enforcement policy to go to market. And the reason here is that the FDA didn't want to be the bottleneck to getting more thermometers out to the market, as long as the manufacturer is testing to and can prove that they meet those requirements. And then as we've continued to move forward here, this state of emergency is extended in 3-month increments. So the last time it was extended in October, and it's for 3 months through into January 2021. And then at that point, we'll see what the determination is, especially with the vaccine and everything else coming out, whether the state of emergency continues. Once the enforcement policy is out of place, any manufacturer who is operating under the enforcement policy has to stop marketing and selling the product until they have a full 510K pre-market authorization from the FDA. And so I talked about a bunch of different terminology here on FDA, and so we put together a little table to try and help frame up the different ways that you might take a medical device to market, whether you're in a state of emergency like the current pandemic or not. And so the way that you would take a class 2 medical device like a clinical infrared thermometer to market outside of a state of emergency would be under a 510K pre-market authorization. And essentially the process is that you go through and you meet all the standards, you submit that information and a application for 510K to the FDA. The FDA looks at it. If it deems that it's adequate, it then clears that product, and the product can be launched and marketed under whatever claims that they've chosen to include within their 510K submission. So that would be how you would go to market when there's no emergency. When there is an emergency, there are 2 other paths to market. There is an EUA, which stands for an emergency use authorization. This essentially requires that there's some sort of public health emergency and that you meet the standards that are outlined in the EUA. You submit this EUA request to the FDA, so you do have to provide some evidence, albeit abbreviated evidence, that you meet. You will be approved of that request, and then you can launch to market under an EUA. And then where most people or most manufacturers are coming to market, particularly with these TI cameras and IR thermometers, is under the FDA's set of enforcement policies. And essentially all this requires is a public health emergency, that you meet the standards, and then you can go to market. Obviously, if you go to market and you're not meeting these standards and customers are complaining about the product and not sure that it meets, and the FDA chooses to audit you, you have to be able to prove that you have met all these standards before you go to market. Otherwise, the FDA could potentially issue a warning letter, or there may be some other type of consequence for launching products that do not conform to these standards. So what does this guidance allow, this enforcement policy guidance allow, since there's no formal approval by the FDA? So what is allowed is that the contact and non-contact thermometers both can be marketed for the EBT screening or fever screening application without obtaining pre-market clearance. The temperature screening products can be marketed, as we just talked about, for this fever screening application, and products can claim alignment to the enforcement policy. But as we note here on the right, in what is not allowed, you cannot use verbiage like FDA cleared or FDA approved, since the FDA has not reviewed any documentation or data from you. You're not allowed to use the FDA logo, make any competitive or marketing claims that cannot be backed by facts and data that you have. And certainly you cannot sell or market the products if you do not comply with the standards outlined in the enforcement policy. And so with all of this, what does it mean for end users, this ability to go to market without submitting anything to the FDA? So there is a chance for end users that you may be purchasing products that claim certain specifications that are not actually being met, because there's no review or data being submitted to the FDA. Products which do not fully comply with the standards may still possibly be sold and marketed under this application, but it should be noted that the FDA has the right, as we talked about earlier, to issue warning letters to companies who are producing and selling products that do not comply with the stated standards. You know, the market is now flooded with hundreds, if not thousands, of different options at different price points that all claim very similar, if not the same specifications. And so there's a very cluttered market that is causing some confusion among consumers. There's a significant number of products in the market with no brand name, no warranties or returns if the product does not perform to its stated specifications. And just in general, it's difficult to determine which products actually meet the standards and which do not comply out in the marketplace. So jumping into some considerations, we'll talk about each of these technologies a bit, but we'll talk about some of the considerations on this on using thermal imaging camera systems. So in general, IR reflections onto the camera and ETRS, which would be your temperature reference source that sits in the field of view, as you can see in the photo here. You may see some IR reflections coming off other objects or things around you while you're being screened that could affect the measurement. And so it's typically best practice to have a white background behind, as you can see in the photo. The area of focus on the face might not be correct on the camera, and so that should be adjusted and looked at. Resolution and uniformity of the camera itself can affect the measurement, and we'll talk a little bit more about that. The footprint of the overall system, especially when compared to an IR thermometer, can be quite large, and often there's a lengthy setup process involved to get the system running properly. So talking about some of the considerations here, we'll start with accuracy and under accuracy, uniformity. So testing accuracy only at the center point of your thermal imaging camera is not sufficient to conclude that you have accurate results across the entire field of view. And we get at this this uniformity by looking at a uniformity specification, which describes how well each pixel behaves compared to other pixels on the screen. And we went ahead and provided an example of what poor uniformity might look like on a screen versus what better uniformity might look like in terms of how one pixel is behaving in comparison to another.
Hey, Michael,
Yep.
wanted to add on the uniformity. The reason why measuring at only a center point, and it might be intuitive for most people, but just in case, I wanted to point it out. There are thousands of pixels on a thermal imaging sensor, and so all of those pixels need to be taken into consideration when you're trying to find the hottest point. So if you're only looking at a center point, you're missing out on a lot of data. So it's like saying you want to measure the temperature of someone's face instead of measuring on their nose, for example, because if you just measure on their nose, you'll miss a spot, or that's an extreme version, right? I wouldn't think people would measure on someone's nose, but even if you measure on one spot on the forehead, you could be missing a lot of information. So that's why we want to take into consideration the entire face.
Yep.
Thanks.
Yep, thanks, Han. So, the next piece on accuracy that makes sense to talk about here is the resolution of the camera that's being used. So, in addition to the examples provided by the FDA, a key essential performance requirement from this IEC 80601 standard is to have a minimum IR resolution of 320 by 240. And we've shown some portrait and landscape views of 320 by 240 cameras, as well as 640 by 480 cameras, to give an idea of how much the face might fill of that camera, depending on what distance they're standing away. But the related requirement here is that you have at least 240 by 180 pixels on the face to get at a 1 millimeter pixel size for each pixel on the face. And we'll talk a little bit more about why the 1 millimeter pixel size here, but that's what can be achieved by this 240 by 180. And then you'll notice that in the 640 by 480 camera, it leaves some extra space in the field of view so that we can get in a reference temperature source to improve the accuracy of the thermal imaging camera system. So here we go, talking about the 1 millimeter pixel size for TI cameras. So again, per that 80601 standard, the inner eye or the canthus, as we saw in the study, is typically the hottest point on the face, and the hottest point on the face is typically correlates best to the internal body temperature. So about 75% of the time that's found on the inner canthus. But the inner canthus itself is very small in comparison to everything on the face. And so you'll notice in the kind of crude picture that we have here, if your pixel size is the size of the one on the left, you're averaging temperatures amongst other parts on the eye that are not just strictly the inner canthus, whereas on the right, you can see that pixel size allows us to just pick out the inner canthus only and try and get as accurate a temperature measurement as possible of the inner canthus in that way. So the pixel size, as we talked about, is determined by the resolution of your IR sensor, the field of view of the lens, as well as the distance the subject is standing away. And typically these systems will specify how far you have to be away to try and achieve these specifications. So TI camera, just general notes on clothing environment. So infrared energy cannot penetrate through glass or other hat fabrics. You can see there on the left with the thermal image of one of our engineers here at Fluke, that you can't view the eyes through the glasses that he's wearing. So if you're wearing glasses, you can't get at the inner canthus, and obviously if you're wearing a hat of any kind, it's very difficult to find the hottest point on the forehead if part of the forehead is covered. Per the ISO TR 13154 standard, ambient temperature where the camera is being used should be maintained between 20 and 24 C and humidity between 10 and 50%. The background, as we've talked about earlier, needs to be uncluttered and non-reflective so that you don't have stray IR onto the camera from screening an individual. And then obviously, and this is true of IR and TI, and one of the struggle points of the technology in general is that wind, air temperature, sun, rain, exercise with perspiration, there's a number of things that might affect skin temperature and then in turn can affect what the subsequent body temperature reading is, given that the body temperature is often determined by an offset from your skin temperature to your body temperature with both of these technologies. So now we'll jump into some considerations around when using IR thermometers. So general considerations for IR thermometers, in general, right, your skin temperature is going to be lower than your internal body temperature, and that's the reason for having the offset that exists both in the IR thermometer and most of the TI camera systems, and that in general temperatures can be inconsistent across the forehead. I'm sure for anyone who's on the line here that's used a IR thermometer, you may get some variability across the forehead, and it's just not necessarily a consistent forehead or temperature across the forehead for every individual. And this could be related to what we talked about before, which is that skin temperature is susceptible to outside influences. These outside influences include perspiration from exercise, ambient temperatures, whether they be hot or cold, as well as clothing or hair, maybe that's across the forehead while you're being screened. And it's important to note that, even though fever is often the first and the most common symptom for COVID-19 at the onset, screening using temperature is not a means of diagnosing if an individual has COVID-19. It is just a tool amongst several tools that we might use to try and screen individuals from coming into a building if there's a chance that they might have COVID-19. And that, again, there are people who are asymptomatic, and so they may not exhibit any symptoms, including fever. And so, amongst all of these things, right, they're all things to consider when using IR thermometers for temperature screening. But if you are using an IR thermometer for temperature screening, there are some general principles for use, especially during this COVID-19 pandemic. Fever screening should be performed by an individual wearing proper PPE when there's any concern of infection, like there is today. So this would include mask, face shield, gloves, etc. The individual who's being screened should remove any obstructive clothing from their forehead, hats, beanies, glasses, etc. And the individual should minimize the amount of outside influence on their skin temperature, whether that is exercise, whether it's coming in from a very cold day in Minnesota or a very warm day in Arizona. Just anything where the skin temperature might be affected, trying to minimize that will result in a more accurate temperature reading. So now we'll jump in with just the hundreds and if not thousands of thermometers that are out on the market today. What is it that you should be looking out for when you're going to purchase one? And so we've outlined some key attributes to look at, and then what you should be looking for as it pertains to those particular attributes. So along the left side, I've got some definitions, but I'll just go ahead and talk to their title and what to look for here. So on the accuracy side, you want to ensure that the product's accuracy is being tested to this ASTME 1965-98 standard. This is the standard that's called out in the FDA's enforcement policy and calls out what the product accuracies should be. And you just want to be conscious of products that are making blanket accuracy claims but are not referencing any of the standards that that accuracy might be tested to. When you're looking out for products, you might also look out for the ones that have a body mode option. So since your skin temperature, as we've discussed, is generally lower than your internal body temperature, you're going to want to make sure that whichever product you're using has some sort of offset to account for that. Emissivity, which is essentially a measure of how efficiently an object gives off IR radiation. You want to look out for products that use an emissivity value of 0.98, as this is the widely accepted emissivity value of human skin. Looking at the EMC performance, you should ensure that the product's EMC is tested to this IEC 60601-1-2 standard, also called out in the FDA's enforcement policy. You might also look out for asterisks within the specifications related to the EMC performance. While not entirely necessary, you might want to look out for products that have some sort of scan functionality, as this helps improve the measurement repeatability when compared to a spot measurement. So instead of measuring one spot and measuring another, you can hold down the trigger, scan across the entire head, identify the hottest temperature. Then every time you do a new scan, ideally your repeatability is improved as opposed to just picking different points on the forehead in consecutive measurements. And then finally, you want to look for some sort of drop test rating to ensure that if you drop the product, it's still going to perform within its stated specifications. And so under that ASTM standard, the drop test rating requirement is 1 meter. And so you want to make sure you're looking out for products that are drop tested to at least 1 meter. So now I wanted to go and talk a little bit about the EBT products that Fluke offers. So we'll go ahead, since we just finished discussing the IR thermometers and what to look out for here, we'll jump into the Fluke 67 Max infrared forehead thermometer. So the Fluke 67 Max features and specifications, the accuracy and resolution and all the specifications outlined in here are defined, tested to, and comply with the ASTM and IEC standards outlined in the FDA's enforcement policy. This includes 0.5 degree F accuracy, 0.1 degree F resolution, a measurement temperature range. So what range of temperatures you might measure across the forehead from 72 to 109, keeping the product at a 2-inch to 6-inch distance to remain within those stated specifications. We've talked about the emissivity. The battery life is at 100 hours for this particular product with a 2-meter drop test and a 3-year warranty, complying again with the standards that are stated here. It's, we'll talk about these a little bit. It's got a body mode, as we've talked about, that adds a temperature offset to account for skin temperature being generally lower than your internal core body temperature. It's got scan functionality, which allows you to scan across the forehead to improve your measurement repeatability. EMC is tested to and complies with the IEC 60601 standard that we had discussed. And then as we've discussed at length a number of times, we do use an emissivity setting of 0.98 as that's a widely accepted value for measuring human skin. So looking at those attributes that we discussed before, how does 67 meet those? Well, the 67 Max product accuracy is tested to and meets the ASTM E1965-98 standard as we've discussed before. It has the body mode that automatically provides a fixed offset between the skin temperature and the body temperature. And then we use that emissivity value of 0.98. EMC has been tested to the IEC 60601 standard to remain accurate when near other devices that you might find yourself around, such as portable RF equipment and two-way radios. We do have the scan functionality that allows you to hold the trigger down and scan across the entire forehead for the hottest temperature. And then the product itself is drop tested to a height of 2 meters, which goes beyond the standard or the 1 meter, outlined in the ASTM standard. And then we'll go ahead and we'll talk about our other product that we've come out here, which is the Fluke FS100 thermal body screening system. So, under regulatory, we come in under the FDA's enforcement policy, as we've talked about, and that's what we do with the 67 Max as well. The accuracy, as defined, as defined below, you can look at the asterisk there, as the difference between the actual and expected readings using a secondary black body or ETRS calibration source is 0.25 C, 0.45 degrees F. We use, that larger field of view 640 by 480 camera so that we have enough room for the individual and the ETRS in the frame of view. We use a measurement distance of about 1 meter to achieve that 1 millimeter pixel size on the face. And then we've got a 1-year warranty where we have face detection, so that as soon as an individual walks up, it recognizes their face and detects for the hottest temperature correction, as well as data privacy controls, depending on the facility needs. So the FS100 addresses some similar attributes as the 67 Max, but slightly different given that we're looking at a 2D thermal image view. So we'll go into this a little bit. So again, the accuracy is tested to what's outlined in the FDA's enforcement policy. The resolution of the FS100 is tested to and complies with the FDA's enforcement policy, as we've just talked about in some of the IEC standards that are called out in there. From a throughput standpoint, the product allows for about a 1 second per person throughput, so it's quite quick, and you get some social distance, which we'll talk a little bit about here. We talked about the face detection, so it offers face detection, but also ensures that you have the correct number of pixels on the face to accurately measure the inner canthus, assuming that's where the hottest point on the face shows up. It also allows for some social distancing. So with the IR thermometers, you have to be within the 6 foot social distance to get within the 2 to 6 inches required by the 67 Max, as well as that typical distance in that 2 inch to 6 inch range for most products. You're going to have to be closer together, which requires proper PPE and everything else. With a thermal imaging system, you can sit much more than 6 feet away at your camera and allow the testing to be done there. And finally, the camera and ETRs are fully designed and assembled and manufactured in the US for the FS100. And that's our presentation today on EBT screening, as well as an introduction to the 67 Max and the FS100. And I'll go ahead and pass it over to Christina for questions, and Han and I will do our best to address those.
Okay, thank you, Michael and Han. That concludes our presentation portion. We'll now move into the question and answer session, like Michael just said. Just a reminder, if you'd like to ask a question, please send it through the question box in your webinar controls. Okay, how is the 67 Max different from other IR thermometer products that Fluke sells? Can it be used the same way as other IR thermometers?
Yeah, thanks for the question. So the 67 Max is designed and it's tested to and complies with all of these standards that are outlined in the FDA's enforcement policy. And so it's got a very limited measurement temperature range, but very accurate within that range to the point, to the 0.5 degree F that we talked about. And so, when compared to an industrial thermometer like what Fluke has produced for a number of years now, they're really intended for different applications, and their specifications aren't really such that they can be used interchangeably. So for an industrial thermometer, you're going to see a very wide temperature range and a much broader accuracy specification, or looser accuracy specification, as it's just intended for a different application. And so if you are needing an IR thermometer for an industrial application, you're going to want to look at some of our industrial thermometers like the 59 Max or Max Plus, or the 62 Max or Max Plus. Those are going to be your best bet. Using those for a fever screening application, you're just not going to have the accuracy necessary, and you're not going to have a body mode offset to try and help you get at the internal body temperature from the skin temperature. And likewise, if you're looking to purchase an industrial thermometer, you shouldn't be looking at the 67 Max, because you're going to have a very narrow temperature range, and it's likely not going to be usable for all the applications that you might need an industrial thermometer for.
And I would add to that, I know this is focused on the 67 Max. On the FS100, similar question around if you can use it for an industrial purpose. In this case, for the FS100, you can, because we do use the TI-480 Pro camera as part of the FS100 system. So you would simply remove the external shutter, remove it off of the tripod or wherever you have the camera mounted, and you are off and running and able to use it for predictive maintenance and your regular industrial use. The reason why we're able to get the accuracy needed for measuring people or body temperature with the FS100 is because of that external shutter attachment. So as soon as you remove that, you're more mobile and you're back to being a handheld device that you can take around your manufacturing site or your facility.
Okay, great. Let's go to the next one. Can elevated body temperature screening be done outside before people enter the building?
Yeah, Han, did you want to take this one? Because well,
Sure.
I can take it from an IR thermometer standpoint, and then maybe I'll pass it over to you from
Yeah, go ahead.
Okay. Yeah, so even though the operating ambient temperature range of the 67 max is from, I think, like 60, 59 degrees Fahrenheit, something like that, to like 109 degrees. We talked about all of the influences on skin temperature that exist outside. And so if you're doing screening before individuals come into the building outside, especially as we're starting to come into the winter months, you're going to have a lot of other influences that like a cold temperature outside. I'm out in Denver right now. It's starting to get pretty chilly outside, and so if you're sitting outside for a period of time, your skin temperature is going to read low, and the offset within the thermometer isn't going to be enough to compensate for that, and so you're going to get generally lower skin temperatures if you're screening outside. And so even though the product is suitable for certain outside temperatures, best practice is to always do the screening inside and to try and have the individuals as acclimated to the inside temperature as is possible prior to screening on the IR thermometer side. And then I'll pass along to Han here for the system look.
Yeah, and everything you said, Michael, is absolutely true. I mean, there is an international standard, and I can't quite remember what the standard name is, but it actually states that ambient temperature, when you're taking the measurement of your body temperature, the ambient temperature, so the temperature in the air around you, needs to be between 20 degrees C and 24 degrees C with very specific humidity, which is 10% to 50%. So if you can imagine, Michael, as he said, he's in Denver, it's cold and it's going to get colder. Taking your body temperature outside is just not going to work. And it's the same for the system view, the FS100 at 100 as it is for the 67 max. In addition, what Michael was reviewing with you before on the previous slides was, wind has an effect. The sun, the rain, it's going to also have an effect. And so with the FS100, the ambient temperature range, and this is per FDA guidance and the IEC specifications, is going to be, for the environment, it's going to be between 18 degrees C to 24 degrees C. So, and the operating humidity needs to be 75% or less non-condensing. So with that being said, there's going to be a lot of places that if you take a measurement outside, it's just not going to work, especially under direct sunlight or any kind of airflow as well.
Okay, this seems to go along right with what you were just discussing. Is there a rough estimate of time that an individual needs to be in an ambient temperature range before conducting the screening?
Yeah, that's a great question. So it's a bit of a balance, right? Because you don't want to. It's almost a catch-22 because you're trying to not screen or let individuals who may have COVID-19 come into the building or stay into the building for very long. But at the same time, it does take a fairly significant amount of time for the human body to acclimate to whichever temperature you're in, depending on what temperature you've come in from. And so I believe the recommendation from the FDA is something in the neighborhood of 20 to 30 minutes. But obviously, there's also still a practicality piece here where you can't have somebody who may potentially have COVID-19 sitting in your lobby for 20 to 30 minutes prior to being screened. It kind of defeats the purpose. And so what I think we've been trying to, and I think our customers have been trying to do, is just allow for as much time as is possible or practical prior to coming inside to allow the skin temperature to acclimate And if there are any erroneous readings or things like that, trying to find or have an area for individuals to acclimate to the temperature a bit more and potentially screen again. And so I don't know that there's a magic number here, but the recommendation from the FDA is about 20 to 30 minutes to acclimate to the same temperature. Anything to add, Han?
No, I think you covered it. And yes, the FDA does recommend 15 minutes, and that's based off of their own clinical trials and their settings. So that's just something to be aware of. It's in a very controlled environment. So when we take it out to the real world, it might be a little bit different too.
Right.
All right. The next question, do these products need to be calibrated? And if so, how long is the calibration interval?
Yes. So any product really that are offering these kind of accuracies that comply with the FDA's enforcement policy are going to need to be calibrated. For the 67 max, the calibration interval on the product is 1 year, and that's 1 year over which the product is guaranteed to stay within its stated specifications. After 1 year, it's just a recommended calibration cycle. We obviously can't dictate when people absolutely have to come in, but it's a 1 year span over which the specifications are guaranteed on the 67 max without future calibration. And then Han, I think it's similar with your system.
Yep, exactly. It's the same.
Gotcha.
Okay, that looks like it's all for the questions that have been submitted. So that will conclude our time for today. If you have further questions or would like to find out more about Transcat's product and service offerings, please contact us at 800-828-1470 or on the web at transcat.com. Thank you for joining us today. We hope that you got something out of today's presentation and that you continue to join us for future Transcat e-learning webinars. Thanks, Michael and Han, and everyone have a great day.
Thanks, Christina.
Thank you, Christina.
Thank you.
Thanks,
Okay,
everybody.
bye-bye now.
Thanks, everyone.